Okay, so let's do this with masses. So literally the voltage at P is just going to be the sum of the potential at P is just simply going to be the sum of the potential due to A and the potential due to B. Okay, so this is going to be what the opposite of G times mass A is 6.3. Right, and then mass A, this is the potential due to A, right? Okay, so it's 1, 2, 3 meters over 1, 2, 3, 4. Doesn't that make it 5 meters away? Then I'm just going to do this. So 3 squares over plus 4. It's a 3, 4, 5 right triangle. 1, 2, 3 over 1, 2, 3, 4 down. Okay, and then it's going to be plus negative G, because remember our formula is opposite of GM over R. Okay, so these are depressions. That's a depression, that's a depression. Okay, this one's slightly bigger than this one. Okay, opposite of G times E12. And then let's see, we are going from P to B, so that's just 1, 2, 3, 4. So it's the square root of 0 squared plus 4 squared. Obviously, you just put 4 there, okay? I'm making a little joke here. But I'm going to type it like that into my calculator because I'm just going to reuse this expression twice. Well, I'm going to reuse it once, but I'm going to use it twice. All right, here we go. Okay, alpha, I'm doing alpha F1. Okay, the opposite of alpha G. See, I stored the constant of G in the letter G. Okay, times 6.3 E12 over the square root of 3 squared plus 4 squared. Okay, and then we're going to go plus, and then another fraction, the opposite of G, times 5.2. And that's over the square root of literally 0 squared plus 4 squared. All right, let's do that. I'm getting that this is negative 170.752. And that's joules per kilogram. And then let's find the potential at Q. That's going to be opposite of G times 6.3 E12, and then that's over the square root of, okay, so Q to A is 1 over 2 down. Okay. And then let's do the potential due to B. So opposite of G, B is 5.2. Right, and then this is 2 over 2 down, right? Okay, do we have that right? Yeah, we do. Okay. So now I'm just literally going to barf this same expression back up. And all I have to do is just edit the numbers I put in there. So 2 squared and 2 squared and woo. It's got it. Okay, where are we? And then that's 2 squared and 1 squared. Don't forget to square your ones. It's very important. Okay, where are we? I think we got it. So this guy is negative 310. Oh, that makes sense. Yeah, this would be lower, right? Because these are both pushing down like the sheet of rubber, right? So if you go from here to here, you're going to go down. Okay, 0.55. So now we're going to go from Q to P, right? So that's going to be a positive amount of work, right? This is lower down, that's higher up, right? We're going from this to this. Okay, so this is our final potential. This is our initial potential. It's always final minus initial. Okay, so the work is equal to the mass times the change in gravitational potential, which is equal to the mass times the final potential minus the initial potential, which is equal to 1.7. And then our final is point P. minus our initial. Okay, so 1.7 times parentheses that guy, whoops, that guy, minus this guy. I'm getting 237.656 joules, or 238 joules with 3 sig figs.